welcome to my channel The Crypto Genesis. In the last video we covered layer 2 solutions including Bitcoin Lightning Network and State Channel. If you haven't seen that video, there is a link in the description. I would recommend you to check out that video in order to understand its benefit to both the new network and users. In this video we will talk about Bitcoin network protocol upgrades, which are Taproot and Seg-Wit. Before moving to today's topic, I want to highlight some basic definitions which will surely help us to understand these protocol upgrades. Bitcoin protocol. The Bitcoin protocol refers to the set of rules, specifications, and algorithms that govern how the Bitcoin network operates. That is, block size, network difficulty adjustment, and consensus mechanism. Protocol upgrades. Protocol upgrades are actually changes in these rules and specifications. Now we'll come to our main topic, which is Taproot. Taproot is primarily a technical improvement to the Bitcoin network. Taproot is a soft fork upgrade to the network that was activated on November 15, 2021. Taproot introduces new features to the Bitcoin protocol, including improved privacy, scalability, and functionality. Taproot achieves these goals by introducing a new transaction format that enables more complex smart contracts while also improving transaction privacy. One thing I want to add here that Bitcoin is added and used primarily for store of value or medium of exchange. It is not designed to support the same level of complex smart contracts and decentralized applications. However, Bitcoin has basic smart contract execution capabilities, for example, multi-signature transaction and time lock transaction, which we have already covered in the last video. Here we will understand it with an example. Let's say you want to pay a friend against some goods or services using Bitcoin. Instead of revealing the details of the transaction on the public blockchain, Taproot enables you to encode the transactions through Merkle tree in a single hashed value known as the Taproot key. When you send the Bitcoin to your friend, the transactions appears as simple, single signature transaction on the blockchain. However, if your friends want to spend the Bitcoin, they can reveal the details of the transaction by providing a witness that satisfies the condition of the script encoded in the Taproot key. This means that your transaction details are kept private and only revealed to your friend when they actually want to spend the Bitcoin. This enhances the privacy of your transaction and reduces the risk of your personal information being exposed on the public blockchain. In addition, Taproot keys can make Bitcoin transaction more efficient and cost effective by reducing the size of transaction and lowering transaction fees. This can be especially useful for small transactions where transaction fees can sometimes be a significant percentage of the transaction value. In the definition of Taproot, we use multiple technical words, which needs to be elaborated further. So first we will discuss detail of transaction. When you want to spend the Bitcoin received through a Taproot transaction, you need to disclose the detail of the transaction script in order to prove that you have met the conditions required to release the fund. This is done by providing a witness that satisfies the condition of the script. It requires more information to be included in the transaction in order to prove that it is valid, as Taproot transactions are complex. This information includes the spending conditions and the detail of the transaction inputs and outputs. In our next video, we will cover inputs and outputs of Bitcoin thoroughly. The next we have is the Merkle tree. A Merkle tree, also known as the hash tree, is a data structure used in computer science and cryptography to effectively and efficiently store and verify large amounts of data. We will see Merkle tree in upcoming slide. Next we have Taproot key. Taproot key is a new type of public key that represents a complex script that can encode or convert various spending conditions. Witness. The witness is a piece of data that provides proof that the conditions of the script have been met. Scripts. Scripts are programming language that is used to enable smart contracts on the blockchain network, which are self-executing contracts that can automatically execute when certain conditions are met. Verification process of Taproot transaction. Taproot transactions are indistinguishable from a regular Bitcoin transaction. The miners verify the transaction by checking that it meets the consensus rules of the Bitcoin network, including the rules for the Taproot protocol. This involves checking the digital signature, witness data, and other details of the transaction script to ensure that it is valid and meets the condition required to release the funds. In simple language, Taproot is a technology upgrade for the Bitcoin network that enhances its script capabilities, improve privacy, and reduce transaction cost. Now we will see Merkle tree in a detail. Here we have 8 transactions, and each transaction has its hashes from HA to HH. Then the two transactions HA and HB will pair and form hash HA and B. Same goes with HCD and so on. Then the hash of transaction AB and CD will pair and make hash ABCD. And other 4 transactions hash will club and form hash EFGH. Similarly, transactions ABCD will pair with EFGH and make one root transaction, which is known as HABCDEFGH. It's showing all the 8 transactions, and it's also known as a hash root. The purpose of the Merkle root is to simplify complex data structure and obtain single hash root in the end that represents a summary of all the data in the structure. Next we have Seg-Wit, which is also known as segregated witness. Segregated witness is a proposed soft fork upgrade to the Bitcoin protocol that was activated in 2017. We will discuss forking in the upcoming videos. Further, it was designed to improve the scalability and efficiency of the Bitcoin network by separating the transaction signature data from the transaction data. Before segregated witness, the transaction signature data was included in the same block as the transaction data, which made it more difficult to process transactions quickly and efficiently as block size was 2 MB. Seg-Wit addressed this by separating the signature data and storing it in a separate block called witness block. By separating the signature data from this transaction data, Seg-Wit allows for more transactions to be included in a single block and reduce the size of the transactions, which in turn reduces the fee associated with processing those transactions. In addition, Seg-Wit was an important upgrade to the Bitcoin protocol that helped to address some of the scalability and efficiency issues that were hindering the growth and adoption of Bitcoin as a mainstream payment system. I hope you found this video helpful. If you have any questions, feel free to ask me in the comments below, and don't forget to like this video and subscribe to my channel.